right? Pascal's triangle is another way we can get these binomial coefficients, and it's very easy for you to construct, right? You've noticed the pattern here. Okay, this is a triangle. It's got one on the top. It's got ones going down the sides of the triangle here, right? And you get the numbers in any particular row by adding up the numbers that are above it to the left and to the right. So like this 2 is here because 1 plus 1 is 2. This 3 is here because 1 plus 2 is 3, right? The ones on the diagonal are there because if I'm in this spot right here, there's nothing over here. So that's a 0. 0 plus 1 is 1. That's why these have to be ones along the side, right? But all these numbers here, 2 plus, 3 plus 3, 6. 4 plus 6, 10. You can make your own Pascal's triangle very easily, right? Just by doing that. And you notice where the numbers get the biggest? They're always the biggest in the middle, right? The farther down you go and always towards the middle, that's where you find the bigger numbers. The first number is always a 1. The last number is always a 1. So that's Pascal's triangle. Now, if you look at the next slide, I think I'll just move on to this one. So let's say that I wanted to do, well, notice this, right? This is the x plus y to the 0 is 1. Anything to the 0 is 1. X plus y to the first power is x plus y. So when it was raised to the first power, you had 2 terms, right? X plus y squared has 3 terms. So notice you're always going to have one more term than the power that you're raising it to, right? X plus y to the 5th should have 6 terms. 1, 2, 3, 4, 5, 6 terms. Okay, we know the pattern of the variables. Like in x plus y to the 5th, it starts with x to the 5th, and then that goes down by 5, 4, 3, 2, 1. The y's, no y's in the first term. 1, 2, 3, 4, 5. The only thing that's left is we need our coefficients. Well, if you're taking x plus y to the 5th, you say, okay, I need 6 numbers for coefficients. So I go back to Pascal's triangle, and I go down to the row that has 6 numbers. 1, 2, 3. So it's right here. 1, 2, 3, 4, 5, 6. So it's 1, 5, 10, 10, 5, 1. And that's where these numbers come from. 1, 5, 10, 10, 5, 1. Okay. Now again, you could, like here on the last row, it's x plus y to the 7th, so there's 8 terms. The first term should have 7c0 as the coefficient. The last term should be 7c7. We know now that those will always be 1. This term here, again, it'd be 7 because the 7 comes from here. That doesn't change. And the second number, the r, it's always the power of y, right? So that's why that's a 4. That's why this one is 7c2 because that's y squared.